Good day and welcome to this Saturday's technical session of the CNPS. I'm Ian Cowan and today is the 25th of October 2025. And we're very pleased to have one of our regular participants, Dr. James J. Keene, back again to talk to us. And this time Jim is he's entitled his talk Physics Follies, and it's quite ambitious in a way. I'm certainly interested because he's claiming, which maybe to a dissident isn't so revolutionary, but he's claiming that false or incomplete theories dominate physics literature by discarding the scientific method and preventing conceptually new approaches. So that may be heresy to the mainstream, but many of us, will relate to that. But I think his next sentence, the next two sentences, or to finish that, they are quite revolutionary. Which theories conform to that? Quick answer: all of them. So it appears that he's going to demolish all the currently prominent theories, and he's claiming that they don't conform to these basic principles that should be followed by all scientific endeavor. Namely, they should be complete and they should, they should follow the scientific method. So, as usual, what we've done, Jim, actually, I've had a quick preview of some of the material. I think he has a lot of interesting visual elements which he'll be alluding to and so on, as well as his text. So, what we'll do is we'll bring Jim up presently, and we'll allow him to introduce, perhaps without putting any of his visual material up, we'll allow him to introduce himself briefly. I think most of us know him, but what he'll be talking about today, what is the actual slant, and then I'll put his visual images up, and I think we're going to do a bit of an experiment today, if you'll all forgive us, and any feedback, of course, afterwards will be welcome. We're going to be a bit more dynamic than usual. So when the text is up, what I normally do is I bring the speaker down so his photograph does not appear on the left-hand side of the screen, thereby maximizing the text so all participants can read it. But then Jim might want to bring in some jocular or revolutionary aspect, and he might have a visual aid or a table or something like that. And when he does that, I may bring him back so you can see his actual visage and his expression. We'll see, does that work anyway? Okay, so I'm just looking to see, do we have people? We don't have many actually coming in yet on the Facebook and YouTube, but I'm expecting that sometimes they're a few minutes late. Although we have a couple of people in on the, there's Vladimir's coming. We have a couple of people in on the green room. So what I would propose as normal, when we finish, we'll address some of the comments or quick questions that have come in on the social media. And again, I would just remind you that most of those comments tend to be discussions between participants and so on. And you're very welcome to do that. But if you have a specific question for Jim, just say question for Jim. Otherwise, I might just think it's in conversation between two people and not address it. And then afterwards, we'll get to the green room, and hopefully we'll have a more detailed conversation with some of our regular participants in the green room. And again, I always say this, I don't think it's ever applied, but it is possible, and I'm sure Jim would not be atrociously upset with me if I did interrupt the session and say, look, there's something urgent that's come up. Somebody's put a question in. This is just so urgent that I just beg that you stop the speaker and we address this. We will do that in extremis. As I say, it's never happened in my memory, but we prefer to allow the speaker to have uninterrupted continuity, and then at the very end he'll address matters. But don't be afraid. If you really are very worried about something that Jim says, you can either say, look, I think this is urgent, perhaps we could interrupt him, or if not, we'll wait till the end. So just to make sure that I don't miss it. Okay. now. Hello, Jim. It's good to have you back again. And
Hello.
thank you very much for coming today. We,
Well,
we
thanks
were
for
actually,
giving me the opportunity.
well,
I'm
that's a
delighted.
pleasure. Yeah, and I can announce that my schedule seems to be full now to the end of the year, and I'm now looking for speakers from January onwards. So you've been helping in that regard. Thank you very much indeed. Um, so what I'll do, Jim, is shall I wait a moment to put the visuals up? Just give you a full screen for a minute or so, just to give us a background or tell us what the purpose of your talk today is, and then maybe
Well,
when you give me the
Ian.
instruction, I'll probably aid.
The luckily the talk has an introduction, so it probably that purpose would be satisfied by just simply that I dive right into the talk.
Okay, well, let's do that then. That's no problem at all. Your materials up now. What I'm going to do is I'm going to take myself down, which means that I'm not audible and I'm not visible either. So if you have any request, or just say, Ian, please. It might take me a second to come back, but I am here listening to everything. And as you said, I have a sort of director's button here. I can uh, toggle around your photographs. So I'm going to disappear now and give you the full floor.
Thank you.
Thank you
Okay,
very much.
well, the title for today's little movie, if you will, is Physics Follies: The Post Game Forensics. In a series of 8 publications from 2015 to 2020, binary mechanics won the century-long physics grand championship race. How? By deriving the measured values of the so-called fundamental physics constants from a new set of postulates asserting full quantization, in boldface, of space-time and energy, replacing the now obsolete theory that space-time and energy are continuous. The losers were dozens of famous physicists, including many Nobel Prize winners, principal investigators in big money grants, and prominent social media influencers. And national labs such as Fermilab and CERN with multi-millions in annual government funding. At that moment, the commentators were photographed saying, and Binary Mechanics Lab has just won the Physics Grand Championship race. This happens only once a century, folks. You're witnessing history, not even a close runner up. In addition to winning the greatest race in physics in over 100 years, other milestone achievements, partially listed in Figure 1, boosted the leadership position of binary mechanics to route level. First, we have, as I just mentioned, the bit function of binary mechanics defeats the quantum mechanic wave function 2-to-1 because it has the best system state representation, representing position and momentum at the same time. The wave function fails to do this and loses the game. As far as the best time development laws in that event, bit operations defined in binary mechanics defeat quantum electrodynamics and quantum chromodynamics. Bit function analysis was the best in the methodological advanced category in particle physics. Space-time energy quantization represented the winner in the most parameters quantized event. In the best physical force mathematical definitions, the weak force debacle was exposed. And finally, the best best prediction of hadron particle structure and energy states was in the 2 to the 42 spot cube hadron states that were defined. Other significant discoveries include the proton levels, intrinsic particle angular momentum, spin. In other words, where does all the revolving of things in the universe come from? Right here, it was defined. The real-time matter antimatter asymmetry mechanism. In other words, the reason for the prevalence of matter over antimatter is in real time, in events happening right now, not something that happened, billions of years ago, as many allege. Elementary particle composition, the Higgs field and boson mechanism, how that actually works, and the Keene scale, law of motion, and motion mechanisms. In addition, binary mechanics publications clearly excluded general relativity as a viable theory. Meanwhile, the best experimental physicists in the best labs and academic physics departments in the world continue to produce data supporting binary mechanics. Way back in 2010, binary mechanics predicted, for example, the fractional one-third charge in the electron. Just a few months ago, a gentleman named Long Ju, that's Long space Ju, at MIT published data in the journal Nature, confirming that 15-year-old binary mechanics prediction of fractional electric charge. In effect, binary mechanics lab has outsourced research projects, as I just presented an example, to an extensive resources. In that sense, binary mechanics is rather mainstream. Given the overwhelming defeat of a substantial number of theoretical physicists, one might expect a flood of congratulations to binary mechanics lab. However, by definition, suffering a rout typically leads to a disorganized retreat. In this case, the losers remain silent and continue to pursue their physics follies as if nothing had happened. We might refer to a hypothetical Fox News report. Binary Mechanics Lab wins the century-long physics grand championship race to derive constants from first principles. CERN, Fermilab, and other big money labs scramble to determine why they lost the greatest race in physics in the last 100 years. In addition, one might expect serious post-game analysis of how the purported leaders in the physics community could be so definitively defeated by the previously little-known binary mechanics lab. In sports, if a top-rated team is roundly defeated, the owner, the coaches, and players engage in detailed play-by-play analysis of what went wrong, if I can say that, 3 W's in a row. How can the defeated team improve to prevent further defeats, they ask. Excuse me. If anyone in the physics community, such as the directors of major labs, did any soul-searching analysis, it was apparently not discussed or released publicly. Therefore, in November 2024, directors of 3 major organizations, CERN, Fermilab, and DARPA, were specifically addressed on X.com concerning this post-mortem review and whether it will be released publicly. One was Fabiola Gianotti, the director at CERN. Will she release their internal post-mortem? Lost the century-long physics grand championship race to our previously little-known lab. And then Leah Merminga, at the then director at Fermilab, was asked, will she release their internal postmortem review with similar text as above? Finally, Stephanie Thompson, the then director of DARPA in the United States, was asked the same question as shown here. Several days later, two follow-up tweets were posted. Specifically, after their defeat by binary mechanics, there was a physicist, and Fabriola at CERN director, Leah at the Fermilab director, and Stephanie at the DARPA director have yet to appear to console them. And in another post, greatest victory in big lab directors are silent. No concession speech, no reforms announced, no solace to their losing teams. With the XCOM addresses therein, the above post probably reached the offices of the directors. We don't know whether those particular individuals received them or saw them, however. At present, it is not known what actions, if any, were taken in response. These lab directors are just one example of a need for frank post-game review in response to binary mechanics victories. Other XCOM posts by the author politely targeted individual physicists, academic physics departments, and national labs both in the US and abroad. The main quantifiable response has been a dramatic and sustained increase in page views of the binary mechanics lab website. This response may suggest some speculative conclusions. First, major participants in the physics community are informed to a significant extent of milestone fundamental physics advances at binary mechanics lab. Second, almost all these participants have thus far not publicly revealed their reactions, including their own postmortem review of their loss. Third, and perhaps most important, apparently none in the physics community have been able to debunk, falsify, or challenge binary mechanics. If they could, they would. Hence, binary mechanics maintains its leading position in theoretical physics. To make matters worse, the winning leading position of binary mechanics has steadily increased over recent years. That is, players in the physics community who have not updated their basic assumptions to the binary mechanics full quantization postulates are falling further and further behind in producing
Jim, my sincere apologies for interrupting at this stage.
Which participants in the physics community. First, we take up are not linearly.
Jim, can you hear me?
Independent. Therefore, they are not fundamental, and they could not be fundamental. This is not realized. There's no way they could be fundamental. That's not
Jim.
Even
I don't know why he can't hear me.
Question you need to ask. Of course, their terminology, these dependencies among measured quantities do not define an orthonormal basis in an abstract vector space. However,
Jim,
countless
can you hear
authors
me?
act as if they do, as if they are literally. This constitutes a very basic math error. This is covered in algebra. And this is you don't need to be a math genius to realize this. And this very basic math error occurs in numerous theoretical physics publications, in my opinion. Perhaps the most famous example of this math mistake is the Planck scale. Based on three unexplained measurements, Planck constant h, Newton gravity constant, what does one get when unexplained values are combined? Answer: more unexplained values. In contrast, primary constants in the Keene scale provide a truly orthogonal basis and are easily superior and are vastly superior to the Planck scale. Another example of questionable math is the Dirac delta function, which provided a sort of quasi-mathematical justification for saying that nothing is really something, as presented previously. In this paper, quantum physicists first invented the nothing burger by using the Dirac delta function in their math. In summary, when one lifts almost any stone in the math landscape of quantum mechanics and the standard model of particle physics, toxic vermin may slither out. The good news is that only three simple math ideas are required to understand binary mechanics equations: single-digit binary number, 0 or 1, the and function, and the not logical function. The little girl here asked, "Mom, what happens when physicists learn I know all the math needed, like yes or no, and logic, like Jack and Jill, and not logic, like change a 0 to 1 or a 1 to 0. Mom, the physicists, they freeze in a state of shock. They spent many years learning calculus, tensors, and very advanced math. When they find out that only three basic math ideas are required to understand how the universe works, some suffer extreme shock, but they'll recover. Many people are interested in physics, but say they do not know enough math. Well, with binary mechanics, they do know enough math, as the little girl just described above, and can understand the basic binary mechanics equations. So that's a little cheery good news in today's talk. Next, let's turn to miracles, magic, and black boxes. The physical interpretation of a point is nothing other than a position in space. This is exactly where magic and miracles entered the physics theory. In the real number scale, a point is a point is infinitely small and merely a location, not something physical. Think of the point particles that people talk about. Unless one wants to add entertainment or magic and religion, in other words, miracles, to science. Do we want to add magic and miracles to science? I don't think so. The standard model strives to define fields for all points in space-time similar to lines going around the north and south poles of magnets, and they're so pretty. With an infinite number of points in any volume, we are asked to believe that some physical mechanism to encode these field values exists at each point, and that this physical field is unique. If that were not enough nonsense, in addition to multiple fields, The standard model math lists a number of so-called operators which relate to how physical events actually take place. And unbelievably, these operators are represented in standard model equations as acting at all points. Goodness gracious. Thus, we have the totally dumb and dumber conclusion that the physical mechanisms that produce events in this world are infinite in number in any volume and infinitely small. Of course, everybody but physicists knows that a thing which is infinitely tiny is not a thing at all. It is nothing. Now, a well-known actor in a big blockbuster movie summed it up this way. One does not simply postulate an infinite number of infinitely small things in any arbitrary volume without calling it a miracle. Case closed. What is the difference between physicists and the clergy in stating their beliefs? The clergy do not need equations in physics books. But, on the other hand, most physicists require miracles that even the clergy deem to be outlandish. These miracles lead to the sacred magical black box, an infinite number of them, one at every point in physical space, hiding the real physics in plain sight. A famous example is the vertex points, where lines and squiggles meet in Feynman diagrams. In field theory, a physicist may compute the voltage potential to describe people doing things on their computers. What it aims at is it wants to know what is happening in the real world. Let's take a look. It is saying at every point there is some sort of black box device. These black boxes are infinitely small. The boxes each contain range-finding equipment and other sensors to determine distance and quantity of charge at all other locations. Each black box has capabilities to reduce this data to a voltage potential. The black box. The boxes are so small that each point in space can contain multiple boxes. Wonderful. One for each field, electric, magnetic, gravitational, whatever field you want to talk about. This description is a general summary, and sorry, it does omit many details. Would anybody believe this hypothetical physicist? I don't think so. In our post-game forensics, widespread belief in miraculous black boxes hated kinders. Just checking how we're doing on time. It looks okay. Imposters is our next topic. Normal development occurs in stages, as all of us know, I think, each of which generally depends on successful completion of previous stages. Excuse me while I die. Actually, I lived through that one. This development phenomena has been described in psychology, sociology, in education, grade 1, second grade, third grade, etc. A bright student who has mastered second grade content, as we know, can skip the second grade, going straight from the first to the third. Why not? This wonderful student, the student has not mastered its content. That student is a pretender, an imposter, much like Ferdinand Waldo de Mara, the great imposter, who pretended to be a doctor without completing medical school and a lawyer without completing law school. Bad things happen when that occurs. Consider a math content sequence, numbers, arithmetic or algebra, calculus, etc. Skipping any step likely results in later failure. For example, one cannot be proficient in algebra without knowing arithmetic. Are there great imposters in physics? I say yes. One might consider this called fundamental physical constants, Planck's constant, etc. 2. Formulate new full quantization postulates. And as a third step, based upon the first two, derive measured constant values using first principles from the postulates alone. Is this a valid developmental sequence? I think so. As an empirical fact, for over a century, use of the antiquated theory of continuous space, time, and to accomplish step 3. That's just an empirical fact. That's history. Can't change that now. It's already written. At minimum, some alternative assumptions in step 2 may be required to achieve step 3. Finally, and perhaps most convincing, in the real world of physics research, binary mechanics has as shown above. If this is a valid sequence of developmental stages, then one can identify many imposter theories and physicists. Prominent among imposter theories are the Standard Model, outdated quantum mechanics, special relativity, and general relativity, all using unexplained measured values in step 1 above as input parameters and failing to provide any credible account of why the constants have the particular measured values rather than some other values. They've completely failed here. It's been a disaster. To be diplomatic, let's let the physicists that may be involved speak for themselves on their position concerning this imposter question. In sum, an imposter effect might be considered in our postmortem forensics. On a positive note, aspiring students and physicists might best avoid imposter theories and teachers. Avoid them like the plague. Avoid them like the plague. Excuse me. Misinformation and disinformation. As most of us know, incorrect information is rampant in physics literature and internet media. Does it matter practically or theoretically that certain groups wrongly and repeatedly describe 13 TeV soup beam collisions, which they are not? A supposed special status for the so-called fundamental constants has been reinforced by descriptions such as they are universal constants, quote unquote, universal in nature, immutable, oh yes, immutable, and non-derivable from more fundamental principles. Well, that one fell quick. That description didn't last long when binary mechanics came along. Misinformation becomes disinformation when intent to misdirect or deceive is added. Something more sinister. No, in any specific case. Do they unfairly deflect attention away from the binary mechanic lead in fundamental physics research and publications? In this illustration here, binary mechanics says, the physics cartel replies, how about I ban and shadow ban you everywhere? Then cousin then cousin Vinny chimes in, "Oh, a counter offer. I'll go with option B. I'll kick your ass by using logic, the numbers, and math." Love cousin Vinny. Honest players might at least cite competing research efforts, such as promising work at Binary Mechanics Lab. Failure to do so may amount to a subtle form of banning, in addition to possible explicit outright banning of binary mechanics posts by social media sites. However, increased binary mechanics page view data suggests that disinformation efforts are not able to deter the internet savvy younger generations, so that it looks like the flow is going our way. Hence, a regime of paradigm change in physics might appear to be inevitable. Scientific method abandoned. As another factor in our postmortem forensics, one of Albert Einstein's teachers, mathematician Hermann Minkowski, defined space-time. It sounds like a ride at Disney World. Defined space-time as a way to describe the location of an object. In addition to the X, Y, and Z coordinates, Galilean reference frame, this space-time added time t as a fourth dimension, expressed as a distance ct, where c is vacuum light speed. That is, the t variable was treated as a position coordinate in an abstract space called space-time, known among mathematicians as a four-dimensional manifold. Forget any general agreement that time is unidirectional, namely an object can only move forward, not backwards in time, known as the arrow of time. Just ignore that CT in space-time is not really like spatial dimensions X, Y, and Z. It just doesn't seem to rise to the occasion. A real physics circus began when people wondered if Minkowski space-time had any use in science. Well, as a preview, it doesn't. As Act 1 in this circus, Hendrik Lorentz added an observer in space-time. Imagine adding a little doll as our observer in an illustration, as they call it. Now the space-time becomes a frame of reference for our observer doll. Now this little observer doll can be a tricky little guy. In this illustration, the student says, "A Chucky doll." The faculty has given one. Chucky doll says, "You must believe the theory." It talks. How cute. Yeah. Wait till later. If an observer in one reference frame of space-time could exist, why not think about other little observer dolls in other frames? Lorentz thickened the plot by devising a way to express what dolls in different reference frames might observe, known as the Lorentz transformation. His Act 1 climax was his theorem. That a moving observer with respect to another stationary observer can use the same electrodynamics. In short, the laws of physics were said to be invariant or equally valid for observers in pairs of these four-dimensional reference frames. In Act 2, Einstein introduced special relativity in 1905. Also, you should really care. It was thrilled and did not care that both Lorentz and Einstein had completely abandoned the scientific method. My gosh, this is becoming a horror show. Where did Lorentz and Einstein go wrong? Time was used as a position coordinate in Lorentz transformations. Thus, time cannot also be an independent variable available to define laws of physics. Why is this? The problem is, even if time does not explicitly appear in an equation for a law of physics, for example, Coulomb's law or the ideal gas law, whichever one, there is the assumption that the equation remains true with the passage of time. Thus, there are two alternative uses of the time t variable: define space-time position or define laws of physics. You can do one or the other. With the scientific method, space-time and laws of physics cannot both exist. If we choose space-time, then there are no independent laws of physics. Without laws of physics, the statement that such laws are invariant across two space-time frames has no meaning. It's pure nonsense. If we choose laws of physics, on the other hand, then both space-time and Lorentz transforms are nothing more than oddities or math protocols, not valid scientific theories with any merit. In sum, when time is used as both dependent and independent variables, the scientific method and its this is not something that you have to figure out. This is just right in your face, explicitly discarded. But many in the physics community crave a good show, featuring the delight of miraculous length contractions and time dilations. Everybody has something they would like to be smaller, right? Or to take more or less time. Nobody cares that a Lorentz transform is not even needed if you already have the information required to do it. In other words, you don't even need the Lorentz transformation because the required information is already there. Mathematics is a huge endeavor with its own history, university departments, and a vast literature. The good news is that very little of this math is needed to understand how the universe works. I try to end each topic with a positive note. Showmanship replaces scientific discipline. The mission of the fake science news is propaganda to hide has been eliminated by failing to account for data. General relativity remains popular for type 1 error, saying that something works even when demonstrably it does not. In addition, the Planck scale has been replaced by the Keene scale, binary mechanics primary constants. The binary mechanics bit function replaces the outdated quantum mechanic wave function. In a loser's game, fringe pseudoscience continues to sell itself as mainstream. Almost all papers on ArchiveX may create an illusion of scientific merit, although it is primarily, in my opinion, a graveyard where reports of low merit work may be buried and forgotten. Companies hosting internet social media promote social engineers, Google it, to influence opinion in the physics community. And limited hangout presentations. Well, what is that? These are presentations that appear to offer insights while hiding real critical content. This limited hangout is a term that originally was developed in espionage organizations. This grandstanding includes popular slogans that quantum mechanics is not understood and cannot be understood. This sort of showmanship may suggest that physics is the only branch of science that does not require understanding and rigorous analysis, and further, that questions should not be asked. Plagiarism and copycats. Plagiarism of binary mechanic publications may be expected, but clear examples are not yet known to this author. Instead, there may be a trend to echo binary mechanic content without citing binary mechanic publications. In this video, which the link has been placed in the private chat and the public chat as well, Jacob Barandis at Harvard may have simply renamed key binary mechanic notions. I'm quoting him now. We need new axioms, division times, quote unquote, indivisible operation, indivisible laws, conditional probabilities. Is this just an innocent case of poor scholarship? Are the new axioms the binary mechanic full quantization postulates? Does division times refer to quantized time, primary constant t? Are indivisible operation and indivisible laws just synonyms in binary mechanics? Barandis cites every conceivable author except the one who published ideas he tries to describe. At 113.10 in the video, he says framework in physics. First, it has to be empirically adequate. The predictions have to agree with what we're seeing. In other words, the data that we observe. Second, it should not be vague. Third, there should at least be a schematic principle story to be told about how the classical world is supposed. There's a whole video that I put out on binary mechanics cosmology doing exactly that. 4, it shouldn't depend on a long list and of ad hoc extra empirical axioms. In other words, everything flows logically from the original full quantization postulates in binary mechanics. He suggests that existing theories fail to meet these minimum requirements, but does not mention mechanics checks all 4 boxes above. Barandis might be counted as a convincing promoter of binary mechanics at a famous academic institution. He just needs some scholarship upgrade to cite relevant sources in binary mechanics publications to maintain in his own integrity as a credible investigator. Antiquated methodology. Compared to binary mechanics, the technology of ALICE, and CMS experiments at CERN is antiquated. The research methods are inefficient and obsolete. Their standard model theory is clearly inferior and out. But in our post-game review, antiquated methodology might have been a roadblock in the path to victory. Mistakes in quantum mechanic theory unavoidably limit its utility in multiple nanotechnology industries, as described in this paper. In contrast, the Mechanics Lab has introduced quantum technology advances, increasing spatial and temporal resolution by orders of magnitude. Imagine the advantage of BML technology in particle physics. For just one cycle of the some 9 billion ticks per second of cesium-133, the binary mechanic time development engine could produce about 10 to 14 frames of this physical process using bit function analysis, one of its new technologies. This frame by frame analysis could examine exactly how a cesium-133 tick occurs. Even better, experiments could evaluate the effects of variables such as GPS systems. With the methodological advance in bit function analysis at Binary Mechanics Lab, the 1950s UNIVAC computer is to modern computing as the CERN Atlas detector and the CERN Alice detector are conducted at Binary Mechanics Lab. Physics researchers and students, commercial enterprises, investment banks, and private equity. Binary mechanics technology can provide unprecedented accuracy and resolution in quantum physics research and levels. Thus, it is a matter of when, not if, the superior accuracy and resolution are widely adopted. Human resources, were they a factor in this situation? The big money labs may never achieve contender stated to full quantization. To be competitive, BML technology may be a required resource at academic physics departments and U.S. national labs, in addition to numerous commercial enterprises. Attracting the brightest, most talented people is part of this competition. You're going to need to have the resources. If you don't have them, the brightest students will go elsewhere. A theoretical physicist growing up, the dad says, one day, son, you'll be a man. The son says, but Dad, I'm 32 years old. Ah, but son, you still fantasize that space and time are continuous. For competence in binary mechanics and its new technologies, U.S. national labs and academic physics departments can sign up for remote video conferences, including basic tutorials and question-answer sessions. Binary mechanics provides a clinic on how to do physics, drop failed assumptions, try new first principles or postulates, log stunning advances, develop new technologies and methodologies. Nobody expected the sweeping and stunning wins by binary mechanics in physics and the resulting loss of leadership by CERN, Fermilab, and DARPA. In this regime change, those with competence in binary mechanics can provide leadership in physics teaching and research. Every academic physics department needs at least one such person. Many of the best, highest paying positions in physics may therefore be filled by graduating students with demonstrated expertise in binary mechanics. Students may apply to have a binary mechanic lab co-sponsor via email or Zoom on their supervising research committees at their home institutions. They can stay right where they are at MIT, Harvard, Yale, Princeton, Caltech, wherever, and have a binary mechanics lab co-sponsor on their PhD thesis committees. Finally, so a demographic factor may play a role in this post-game review. Prior to the binary mechanic victories, power in the physics community was mostly held by older people populating chairmanship in grant applicants at research organizations and in government funding agencies, those who reviewed those grant applications. While this demographic may have the latest in software, when it comes to science, they tend to retreat to their caves and ancient analog computers, like the one I showed in a illustration above. In contrast, younger generations may more easily jump into the binary mechanic full quantization postulates like duck. With their greater exposure to computer games, they know that continuous space is an illusion produced by little pixels and on sufficient game frames per second. In other words, excuse me, in other words, this demographic already thinks in terms of quantized space and time. So they're way ahead in this game. Multiple theories of everything. Do they exist? Binary mechanics may be viewed as a theory of closed toes. What happens in only one of them? Answer. You probably know the answer already. Binary mechanics derive measured values of so-called fundamental constants from first principles alone, winning the century-long physics grand championship race. So it's the only toe that did that. Logic dictates, therefore, there can only be one toe that is both complete and correct in its irreducible representation. Now, this is why we need equations in a scientific theory. With those equations, we can then determine if in the irreducible representation of the theory, one theory is actually different from another and exactly how it is different, or in fact, or maybe it's the same. At present, but multiple possible theories of everything. On the other hand, there can be and are multiple imposter theories of everything. One can list signs that a theory of everything is an imposter. Maybe one is enough, namely that so-called fundamental constants are used as input parameters. This is pretty much the kiss of death. Hence, pursuit of fake imposter theories of everything might be an obstacle to consider in this post-game review. Unwarranted assumptions. Well, admittedly, the centerpiece of this analysis of why binary mechanics easily dethrone previous leaders in physics is unwarranted assumptions, namely the now obsolete theory that space-time and energy are continuous. Essentially, all the low-hanging fruit of this theory has been harvested. It's sort of game over. At present, it is an obstacle to achieving the goal of physics, which is further understanding of how things work. The kid asks, Dad, why can't physicists explain how things work? And the dad replies, without hesitation, we believe that space and time are continuous. That's why we can't explain how things work. Excuse me. Special and general relativity, the standard model, and outdated quantum mechanics live in the same leper colony. Ironically, many of the losers hang on to the make a right rule that my mother taught me. In contrast, binary mechanics rolled out different assumptions, namely the full quantization postulates, as a potentially better unifying idea. Looks like it is. After pursuing the logical consequences of these new postulates and winning major victories, binary mechanics has no real competition. Now, should physicists be sad? The little girl asked her mom, "Why are so many physicists really sad?" The mom replies, "They can't match or surpass binary mechanics lab in science. Because why? Because their theory of continuous space-time does not work. Simple as that. We don't have to get much more profound than that. In recent trends, physicists are starting to demand that their theories actually work. Quality control in the physics community is suddenly attracting interest. Binary mechanics appears to be not only beneficial, but also a requirement for investigators in 21st century physics. What if some bright space and time are each continuous, to derive the measured value like binary alternative postulates? We we can't say that this could not happen. This possibility cannot be excluded. Maybe somebody will do that. But the fact remains that this has not yet occurred in well over a century. On the other hand, with the alternative axioms of full quantization in binary mechanics, these constants were derived from first principles alone. The Keene scale was discovered, and its values, the primary constants, were identified. This is water under the bridge. History, we can't change that. There's no rematch. There's no second chance. Binary mechanics may be logged in as the new shiny thing in the physics world. Discussion. Binary mechanics registered a series of stunning wins, defying all the odds makers. How did this new kid on the block defeat the high and the mighty, including many prominent physicists? With post on XCOM, Binary Mechanics Lab asked. However, if any in-house reviews of these events were done, none have been publicly released thus far. Maybe whistleblowers might surface. For government FOIA requests. Meanwhile, this article tried to examine some of the possible causes of this debacle and dramatic change of leadership in physics. Reality meets fantasy. The prominence and often dominating influence of physics follies causing loss may suggest that many physicists might actually like them. Strange thought. Yes, nobody likes losing. But on the other hand, with this, maybe discarding the scientific method is an attractive alternative. If one has failed to understand what is happening, just make this ignorance a point where lines intersect in Feynman diagrams. If one cannot explain the mechanism of motion, just draw a vector representing displacement of an object. A wonderful thing about fantasy and the physics follies is that everybody can stumble along together around the racetrack. What happens if one horse is increasing? Soon, everybody is watching the winning horse. Of course. Here is where reality meets fantasy. It's like, or that reality was the unexpected win of the physics grand championship race by binary mechanics. Suddenly, the great masters of physics found themselves in the loser's circle as shocked bettors tore up their losing tickets. Even worse, was nobody to bail them out. The research organizations and funding governments make everything happen. And let me try that one again. Two, even worse, there was nobody to bail out the funding governments. After the race, the losers were left alone to fend for themselves. In other words, there's no savior coming for you if you're in the losing camp. You'll have to pull yourself up by your own bootstrap and using your own intellectual abilities, which I believe you do have. What is next? The physics community might explore reforms which foster success in research and deter failure due to known physics follies. In addition, hope may be found in a new physics gold rush. Are you tired of being one of hundreds of co-authors? Join the migrating physicists headed for binary mechanics. Yes, losers of the century-long physics grand championship race, Fermilab, CERN, their government-funded principal investigators, etc., can become competitive again in fundamental physics research. It is not too late to join the party. Binary mechanics has only begun to scratch the surface of possible fundamental advances spanning the subspecialties of physics, the many subspecialties. So this is an optimistic conclusion. For the physicist who determines the correct bit operations order, equation 17 in reference 10, which is titled Binary Mechanics Postulates, the scientific merit of that achievement could easily exceed a handful of Nobel Prizes. Not just one, maybe half a dozen. Nearly every binary mechanic publication suggests where new work may be beneficial. Pilot studies that need replication with larger sample sizes providing better estimates of quantities and their confidence in the cesium 133 with variations of specific independent variables. New applications of binary mechanic predictions and results need further exploration. Be one of the first to cross those finish lines. And thank you very much for your attention. Sorry about the coughing. I smoked too much, I admit it.
Well, thank you very much indeed, Jim, for that quite illuminating presentation. There's very much material there for reflection. And I'd just like to apologize first. Excuse me. Don't worry about the coughing. You are breaking up, actually, your line a bit, unfortunately, Jim. And I did come in. By the way, I hope everybody can hear me now, because you didn't seem to respond. I think you might have muted any interruption, which is fine. But I was going to suggest to you that you actually turn off your video to give you an enhanced bandwidth when you were talking. But anyway, I hope that didn't upset too many people. You were breaking up at times. And there was one other small point, if I may, on this Barandus video, the link. You gave, in the first string, it says U2.be, youtu.be. I take it that dot is incorrect. It should be YouTube. Is that correct, Jim? You had HD.
Yeah, I just copied and pasted that from YouTube itself.
Okay, well maybe it's right.
If you
it just looked wrong that it said HTTPS.
let me click it. I'm going to click it right now and see if it comes up.
Because you had youtu.be.
Okay, loading.
It looked wrong.
Let's see if that video comes up.
I'm sure people will like to look at this later.
Yeah, as I said, I just copied and pasted that from the
correct.
video itself. You can right click on the.
It must be correct.
Yeah.
And I must be
and copy the link
too deeply into what it looked right.
My computer time to load it.
Yeah. Okay. Well, look. If it doesn't work for people, as you have it there.
Well, I'll stop the load. It's going to be.
Yeah, just delete the dot and put in YouTube.
But anyway, if that's not the correct link, look for.
Barandas, is that the name? Barandas.
If that link does not work, just go to Google and search for Kurt COE theories of everything.
Yeah. Okay. Okay. Well, thanks very much. Right. Well, maybe just before we get into the discussion, and thank you very much. A few minutes over time, but that's no problem. We were delighted to have you go into all that detail. You've gone to a lot of detail with the text there, and also the little cartoons.
Hopefully, the breaking up.
Yeah. Because you seem fine now.
Hopefully, the breaking up of my sound did not interfere too much, because I was simply reading, for the most part, what was.
Yes, quite so. No, don't get me wrong. You are actually breaking up a tiny bit now, but it's not too bad at all. And of course, you had all the text there, so don't worry about that at all. So maybe just we'll get into the discussion now quickly because we're running out of time. But yeah, the whole concept of GR would be excluded by binary mechanics. Now, yeah, and I was interested in your point that
that's excluding GR.
Yeah. Yeah. I'm just commenting on one or 2 points, if I may, and I have one question for you before we get into the discussion. So the second comment, which probably doesn't need a response unless you want to make one, is that I was interested in your suggestion that the physicists are introducing more miracles than even the clergymen into their respective areas of endeavor. But the one question I had was this. It just occurred to me. It was maybe not specifically mentioned in your text, but it occurred to me that maybe these professional scientists in the mainstream, and you
in a video conference.
Okay, just hold on a second till I complete the question, please. It suggested to me that you mentioned these very impressive mainstream establishments in the USA and so on, and it occurred to me that these scientists may be getting an easy time of it, because whenever they're interviewed by, say, the media, which echoes what they're saying, the media would never dare question something a scientist would say. They come on and they're all very quiet and they're in obeisance to them. They say, "Oh, you're an expert. I wouldn't understand that." Whereas when a politician comes on and he claims to know about economics or political economy, he's questioned by the media. They say, "No, that must be wrong." So the scientists are getting a very easy ride of it because they've got this aura of infallibility, what perhaps the clergy might have had in the past, and they're not being taken on by the media. Do you think that might be a factor? And are not making any progress.
Well, for me, I don't know for others, but for me, you're breaking up, Ian, a lot.
Oh,
And I don't know
okay.
whether it's my connection, I stopped sharing my screen, or your connection, but you're breaking up. But you were making some good points that I did hear, that scientists are treated better than some others by the media, are offered more deference by the
Yeah.
media. One point I
Okay.
tried to emphasize is the sort of inevitability of some dramatic that are in store. So stay tuned. For example, this my analysis of the demographics, the younger generation. This is a statistical effect. We don't mean that old folks can't understand these things as well, but in general, I was emphasizing the younger generation takes to binary mechanics postulates like ducks in water. In other words, they don't stop and say, binary mechanics, let's look at that. Man, that is weird. Whereas the older demographic, believing their whole life and all their math training focused on learning about the consequences of continuous space time, calculus, tensor algebra, and so forth. When they look at binary mechanics, they say, that's weird. But the younger generation that looks at binary mechanics and they say, well, of course, obviously,
Okay.
things
Well,
are quantified.
that's a positive note, and
So
we
when you
hope.
have that demographic, people analyze demographics in terms of economics, saying that certain things are going to be inevitable. For example, as a population ages, pension funds will run out of money and resources and so forth, that the younger generation won't be able to take care of the older generation and so forth. Well, I'm doing the same sort of demographic analysis in the presentation today, indicating the inevitability of the primacy of the binary mechanics full quantization postulates. There's really no way to avoid it, because the people who say, look at it for the first time and saying, that's weird, that's unusual. And even I've had PhD mathematicians tell me they don't understand it when the math is so simple in what has been presented. For example, in the major paper, binary mechanics postulates, quote unquote. So the older generation is just simply dying off. Pretty soon there won't be anyone saying that binary mechanics is weird. They'll be saying anything other than binary mechanics is what is weird.
I'm a little concerned
I hope that
that
came through
we do
without
seem to be
breaking up,
talking over each other a little, and I think maybe the lines are breaking up. It could be partly my system. I just hope other people on the call, don't have this problem. But anyway, before just coming to the more general discussion, I would just say, well, as I say, that sounds very optimistic to me, and maybe it's because. As you say, the older generation have been infused with this idea, and the ideas of binary mechanics are something that the younger people can adapt to. But I must confess, somewhat pessimistically, that I'm not very happy that the younger generation are any more objective than the older generation were. They're taking in. I'm not talking about binary mechanics now. I'm talking about politics and opinions and what they're taking in from the media and the politicians. So I hope you're right that they are more open. But by the way, I think we can pretty quickly come to the green room, because while you were talking, Jim, I've gone through all the comments, and I can tell you that they're really about the Comet 3i Atlas. So I don't think that's really relevant to today. I think there was one suggestion, and I'm not sure why he was raising it. I thought he might have been attacking you a bit. He said, "Oh, but all these constants are measured constantly all over the world in different labs." I think he just made that comment. I've forgotten some other gentleman here or person, but anyway, it probably doesn't.
Well, I don't disagree with that at all. Of course, they're measured all over the world.
Yes,
that's the point. That's step one in the developmental diagram I provided.
You're concerned whence they came. Okay, well, the green room now. There are a number of people in the green room, and the number are in just a while ago, but they don't have their videos on.
Well, what has?
Say again. What were you saying, Jim? Just before. So what I was going to do is I will invite them in, but if anybody wants to raise his hand, I'll bring him in first. I think it's Nick there. Yeah, I'm just looking. So I'm going to bring Nick Percival in. Nick, good day. You're welcome. What points would you like to put to Jim? No, you're mute. You're mute. You're mute, Nick. You'll have to unmute yourself.
Jim, thank you for that great presentation. I love the style that you were.
Well, that means a lot coming from the great.
I think that style is probably perfect for a CNPS audience because while some of them points were kind of stated humorously and maybe overstated, I think most in the CNPS would agree with your assessment of currently accepted theory. So that was great, and thank you for putting in all the time. And it was the most enjoyable presentation. I was smiling virtually all the time and occasionally chuckling out loud. Also, thank you for your taking a totally different look than mainstream at physics. I think that's the whole purpose of CNPS. You may not have dotted every I correctly or crossed every T, but we don't expect that. We have a new view, a new perspective. The thing I might warn you against is
you're very kind.
Being a little bit myopic. For instance, you talked about special relativity and general relativity and their problem with space-time. And you're, I think, totally correct on one of the problems, and that is treating space and time as continuous. However, I think there are other problems. So you should be open to viewing that BM is not necessarily a total solution to all of the problems of academia physics. For example, I think in special relativity, and this was eventually carried over to general relativity, there was a focus on the inertial frames as a set. The set of inertial frames is playing a special role. But this caused really sucking out all of the physics and putting it into an abstract math context. For one thing, since their interpretation of the relativity principle, it meant there could be no preferred frame, which went even deeper and meant that they ruled out the interaction between physical entity A and physical entity B, which is the heart of physics, and made it into purely abstract laws that didn't focus on, it was not built on the interaction between two physical entities. And one other point regarding the Lorentz transformations, your criticism of Einstein's Lorentz transformations was right on track there, right to the heart of it. However, even though you said that the Lorentz's original transformations and Einstein's had a quite different interpretation, you sort of thought those criticisms applied to the Lorentz's original Lorentz transformation. So let me just make a quick point about that. First of all, Lorentz's ether theory said there was one physical theory. And the transformation was to what the naive view of the observer in other frames who was unaware of this single preferred frame and just naively looked at his measurements without considering what the effect of his motion with respect to the ether was. So that's quite different. And he did not deal with time. He dealt with proper time, which is an excellent physics construct that's absolute and observer independent. And it talks about, it's built on, say, the number of ticks in the clock, and it's inherently non-continuous. But that's the side. It's proper time, which is an excellent physics problem. So your criticisms of Lorentz's Lorentz transformation was off track, and we can talk in detail about that for the time. But closing points. I sincerely hope that you live, so I don't want you to do any more smoking.
Well, so have you
right
any
there.
response, Jim, to those points of Nick's?
Well, the esteemed Nick Percival has raised some new items which can be added to the gold rush that I described. In other words, there are a number, so many new questions that need to be addressed, and there are many opportunities for physicists and researchers and students in that respect, and so that they might be quite optimistic about the future in terms of binary mechanics postulates. Yes, the Lorentz transform is considered in this presentation to be pseudoscience. It's not even in the category of science. It's a math protocol, and we found that only 3 basic items of math is actually needed. So God bless the mathematicians. They're wonderful. They have their own physics, their own mathematics departments in colleges and universities, a vast history and literature, and they're doing wonderful things. And maybe some of those things might be relevant to fundamental physics. On the other, and most of math is required in statistics. And by the way, physicists actually just co-opted what statisticians had already done in principal axis factor analysis of data to talk about the eigenvectors and
Eigenvectors, yes.
values in particle physics, so that physicists really haven't come up with.
You're just breaking up a little again.
Maybe something that goes beyond the Lorentz's
And the
transformation.
comment
I'm
of
just
Nick,
making the point that
with regard
your
to
criticism
absolute,
of Lorentz's transformations are inaccurate.
Yeah, okay, Nick, just a second. Yeah, Jim, we lost you a bit, but if you'd like to come back, because you're breaking up, or are you finished?
Yeah. At what point was I lost?
Uh, just when you were talking about, the mathematical concepts being useful in physics, like eigenvalues and things like that. I think we lost you there. And Nick made another point, but I'm not sure if you heard that. So
Well,
maybe
yeah,
if you just finish.
those mathematical methods were borrowed from statistics by physicists, and so that was the direction historically of what happened. Psychologists and sociologists and so forth and statisticians were talking about principal axis factor analysis with its eigenvalues and eigenvectors long before physicists even brought up the idea. So as far as the Lorentz transform, it's basically, as I pointed out, not even in the category of science. So that if one wants to talk about it all day, that's fine. I have no objection, as long as we don't confuse it with anything that pertains to science and physics.
Let me respond to that. All right. You continue to talk about the Lorentz transformations. There are two totally different things. In your mind, you were talking about Einstein's version.
Well, actually, in the video,
Lorentz's original transformation was good physics. It may not have been the last word, but it was talking about the interaction between a moving object with respect to the ether. So the interaction of two physical entities. That's physics. It wasn't space-time, and as I said before, it wasn't even time itself. It was proper time, which is a very good physics entity.
So if I might just try to understand that, Jim, from Nick's question, may I just ask, accepting a universal frame or accepting a type of ether a la Lorentz, do you have problems with a length contraction and a time dilation? Is that where you have a problem?
Well, in Lorentz's original Lorentz transformations, there is no time dilation. There is also no space contraction. What there is the slowing of the physical process that is running the clock. For example, in atomic clocks, it's the slowing of the cesium-133 cycle, ground state cycle. In terms of length, it's not the time dilation, the expansion. I mean, it's the shrinking of the measuring rod, not of space itself.
Well, he talks about the shrinking of the electrons, when they're moving in a particular direction. So whatever interpretation, I'm asking Jim really, do you have some contention with regard to those concepts, if they're explained in the terms Nick has given or not?
As long as we frame the discussion as something that we're not talking about science now, or reality. We're talking about fantasy, and I have no problem with it at all. Because Nick said
Lorentz's original transformation. You got to go back and read Lorentz ether theory, because it's nothing to do with what you're thinking about. It may be wrong physics, but believe me, it's definitely physics as opposed to pure math. Einstein got off on pure math. For one thing, and of course he was helped along by Minkowski, by his coming up with the construct of space-time. But Einstein was talking about laws of physics being conserved across all inertial frames. And that's where he really went wrong and sucked all of the physics out of special relativity. And then...
Well, gentlemen, would you permit me to encapsulate this, because we have to move on now, and correct me if I'm making a mess of it, Nick. I just want to ask Jim, maybe for a final word, do you conceive of a difference between the Lorentzian original theory, which is a physical theory, as Nick has basically said, and Einstein's development of that into sort of like a mathematical concept? Do you perceive a difference there, as Nick is saying? I think that's all we can really address today. Or do you think they're the same thing? I don't know if I just want to get a quick summary, Nick, and I just want to get a almost yay or nay answer from Jim. Because,
like, if we realize that, well, for one thing, in my presentation, and as I know the Einstein, and
yeah, you're frozen there. Okay.
Well, in my presentation,
I think we're really going to have to address this privately. Maybe
the Lorentz transform. So Nick said that I started with Einstein. In the presentation, it started with the Lorentz transform.
Okay, so perhaps you're not accentuating that difference. You're just taking the Lorentz transformations. Yeah. Well, could we move on? Maybe very quickly, Nick. Very quickly, please.
Yes, one second. The Lorentz transformations, the two versions, look mathematically identical, but because the velocity term has a totally different meaning, that means the physical interpretation is totally different, actually opposites of each other in the physics spectrum. Went from one good physics description that may be surpassed in the future to a pure mathematical fantasy. And Jim's comments applied to Einstein's version of the Lorentz transformations, but not Lorentz's original transformation.
Jim, just to interject, there are some comments coming in that if you turn off your camera permanently, it may improve the quality of the audio. So perhaps you'd like to try that and see if it's any better. And then you could answer maybe Nick's last point. If you turn off your camera. I know it's a bit of a nuisance, but let's see is it any better now, Jim, if you start speaking. Still can't hear you. So it's making no difference.
Well,
thank you, Jim, for a great presentation.
In response to what Nick was saying.
Thank you. If you could be brief.
Well, Nick
Jim,
is talking.
There are other questions coming in, which I'd like to put to you before we finish. I think if I may say so, there is a bit of a different emphasis on the two views that you're expressing. So I think maybe that's all we can do for the present. Nick has turned off his camera as well, but we're not getting any better audio. So Thank you very much for raising those points, Nick. If I may, for the moment, just bring it down, remove you there, and I'll keep Jim up. Now, Jim's removing of his video doesn't seem to have improved matters, I regret to say. But one of the things about being a moderator is that you're omniscient. You can see everything. And I see Vladimir has been walking up and down, pacing up and down. And it reminds me of the story that Bertrand Russell's star pupil, the Austrian philosopher Ludwig Wittgenstein, would come to his rooms in Cambridge at 2 a.m. and he'd just pace up and down, up and down. And he'd be saying, there are two propositions, P and Q. Two propositions. So Russell said, well, what are these two propositions? And after pacing up and down for a few more minutes, Wittgenstein would say, P and Q are indefinable. So he was getting nowhere. But I'm just wondering, Vladimir, have you anything you'd like to say? Because you seem to be pacing up and down. I'm just wondering. So maybe briefly, if you have anything you'd like to put to Jim before we finish.
You know what? There is a very bad communication today. That's why it's very difficult to talk to each other, to understand each other. It was so difficult to hear very good presentation of Jim, but unfortunately, breakage was replaced by text. You can read whatever is missed by audio. But to talk right now, let's continue our discussion tomorrow on our group. And then I will tell my opinion about binary mechanics, the difference between quantum mechanics, classical physics, and so on and so on. Let's go tomorrow in our group, and I will tell you my opinion about it. And I hope it will be good. Listen to me.
Let's do that, Vladimir. Yeah, I look forward to that, and I'm hoping to participate tomorrow.
Let's go tomorrow.
I think Jim will as well.
Yes.
So thank you. We'll move on, and we look forward to maybe having a bit of a post-mortem discussion tomorrow on that. Now, I see Denny is there, and Denny actually has raised his hand. I was going to ask him anyway. Denny, you're welcome there. I think the audio problem is with James, so I think if you speak now, we should be able to hear you.
Okay, well, my objection to binary mechanics is that according to Dave Bergman's mind, electron and proton modeling, which then leads to a neutron modeling, is that the mass and the charge do not have to be unique. There could be a distribution, say a bell-shaped curve, with a very small, even though the mean would be very small, the standard deviation would be even smaller than the mean, and hence, if in any ordinary experiment, it would appear that the mean were actually had a zero standard deviation, whereas it might have instead actually a very small standard deviation relative to the mean. And I don't see how he can fit that possibility into his binary mechanics, but I'll give him a chance to know.
So Jim, did you get that? Denny,
I think that what our dear friend Dennis just said, is perhaps inverted. If the standard deviation is very small and the mean is non-zero, it is likely that the result is, or the conclusion is that the measured parameter is not zero. Whereas he said it would be zero, or estimated to be zero. So it would be estimated to be zero in exactly.
Then I misunderstood what you said, Denny.
The
Is
mean
that
would
not
not
correct?
be zero. The mean would be what is ordinarily thought to be the exact value of each electron. For example, the mean would be the value that is considered to be measured of the electron's mass and of the electron's charge. Excuse me. But
Okay.
so the standard deviation would be small in regard to the mean, but the mean would definitely not be zero. The mean of the electron mass we could look up in the books, and that would be what they claim that all electrons' mass is equal to. And the mean of the electron charge would be the usual quantum of charge. But the standard deviation would not be zero. And so James Keene has misunderstood me.
Jim?
Well, what exactly is your point?
Well, my point is, let's say I
In
can't remember what
measurements, there is variation. So I don't understand what your point is.
You're referring to
Well,
your own model with David Bergman, I think, Denny.
yes. The mean of the electron would be what it's considered to be the exact mass of the electron today. But it's just that the standard deviation about the mean would not be zero as considered today. The standard deviation would be non-zero but small with regard to the mean.
Well, who is saying
the
that the standard
uncertainty-
deviation would be zero? I've never heard that sort of construct before. Who exactly is saying that the standard deviation should be zero? Or is
It's
zero?
believed today that it's zero because the accepted mass of the electron is assumed to be the mass of exactly every single electron has the same mass. And it's every single electron is believed nowadays to have the same charge.
Well, that is a theoretical statement. If measurements are actually made for electron mass and electron elementary charge, as far as I know, there would always be some variation in these measurements, and therefore there would be a calculable standard error of the mean. And so I don't really understand what your point is, because in science, when we measure things, we don't get exact values. We get our measurements.
Yes. But,
and our measurements have variability.
That's just because there's measurement error. But if you were to assume for a moment that there was no measurement error, it still could be that there would be a distribution about the mean, and that distribution would not vanish.
So theoretically, if you were to do measurements on two electrons.
Well, if that occurs, I would like to see you demonstrate that.
Well, I've contacted a statistician.
I don't have a dog in this race, so that.
Okay,
Jim. I think Denny wanted to add something there.
So you're saying
I've contacted a statistician at UC Berkeley, my alma mater, and he believes that it is possible. What he said, in effect, is that it might be possible to, if the mean standard deviation were large enough, even though small with regard to the mean, it might be possible to devise an experiment where you could show that the measurement error was too small to allow for the deviation observed.
Well, that sounds interesting. I don't see how it relates to my presentation today, but
Well, you
I wish you
assume
well
that
on that.
every electron has exactly the same mass, don't you?
So I don't know
That
if I
every
understand this
electron
correctly or
has
not. But
exactly
are
the
you
same
gentlemen saying,
mass.
Jim, is it basically under your system that there would be a unique electron mass, say theoretically, if one could measure it? Whereas, are you saying, Denny, that one electron, if you knew exactly what its mass was, it would not necessarily be exactly the same as another electron mass? There's a variation.
Yes,
Yeah,
yes,
okay. I'm seeing what you're saying. I'm not agreeing with one or the other. I'm just trying to understand.
yes, yes.
So, what do you think of that concept, Jim? Is that
Well,
contrary to your
if it
ideas?
clarifies the position of binary mechanics,
Yes.
if it clarifies the position of binary mechanics, mass is used in two different senses. One is in the definition of the primary constants. The second is in evaluating Newton's law of force equals mass times acceleration. In fact, the data which I have presented in binary mechanics shows that, for example, that the proton and presumably the electron mass actually varies and is dependent upon the energy density in the volume being examined. And so we have on the one hand the primary constants, uh, the so-called Keene scale. On the other hand, Binary Mechanics Lab has produced data and published data showing, for example, that proton mass varies according to the density of energy in the volume being studied. And it can vary tremendously. So that, in other words, the position of binary mechanics would therefore be that conclusion that studies assuming a constancy of proton mass and electron mass are misguided or wrong.
So, what would be the standard?
That's the binary mechanic result.
Jim, what would be the standard conditions that you would be, or binary mechanics would be, producing these results for? I mean, just like when we talk about a gas, we talk about standard temperature and pressure because it properties vary. So, you know, what's the energy density, etc., under which the values that you give would be measured?
Well, it is close to about 0.23 to 0.24 of the maximum energy density which is possible on that scale, which goes from 0, which would be absolute volume, not partial volume. Absolute volume is defined only in binary mechanics, and 1, which is that every possible location that could be in the one state is in the one state. That would be the maximum energy density, which, by the way, more or less agrees with estimates by astronomers of the mass of neutron stars and so forth, or black holes or what have you. So the Keene scale in binary mechanics is in general agreement with observations produced by others in various fields of physics, subspecialties in physics, and in astronomy. I hope that clarifies.
Okay, well,
by the way, I think it's a new result of binary mechanics that these I think it's a new result in binary mechanics that these mass estimates vary as a function of energy density in the volume examined. And this is explored in a paper on the binary mechanics site about the proton-electron mass ratio, which is nominally about 1836 to 1. However, this ratio changes as a function of energy density, which is
Do you
a
want the
new
absolute
and
value
very
of that energy
interesting
density,
result.
Denny?
So that if that is
What?
Would you like to have from Jim the absolute value of that energy density rather than the fraction between 0 and 1 of the theoretical value?
I don't understand the question.
So, like, Jim hasn't given a value of so many joules per cubic meter or whatever the value is. He's just said, well, it can vary theoretically from a 0 to the maximum energy density, and the properties, these fundamental properties, are a function of that energy density.
well, actually, Ian, I have given a value. Actually, Ian, I have given a value.
In
All
other
you
talks,
need to
Jim,
do
is it, or today?
is to no, well, yeah, in other talks, well, actually in papers that I presented and
Okay.
published,
Yeah, I suspected that,
that
actually,
value
although I don't have it
would
at hand.
be about 0.24, would be about 1/4 of maximum energy density. Maximum energy density
Yeah, but what is the maximum energy
defined
density?
in terms of joules.
Yeah.
Well, it would be the primary Keene scale mass constant divided by the volume determined by the length constant. That would be maximum energy density. That approximates maximum observed energy densities in, for example, astronomy and people thinking about objects such as neutrons, stars, etc. And by the way, further looking at this is part of the new gold rush that binary mechanics inaugurates.
All right. Well, I think we're going to have to stop it now,
So
gentlemen.
if you,
So,
well,
yeah,
so
we've run out of time, Jim. Denny, can we leave it at that in regard to your question?
Yeah, go ahead.
Okay. Thank you very much for your contribution.
You're welcome.
Yeah. Sorry for cutting you off, but Jim, you will have a moment or two. More in the summary, because what I'm proposing, as usual, is I'm going to give you the floor now for as long as you want. You could take a couple of minutes if you wish to summarize what you've done, maybe to address some of those points if they can be addressed very, very briefly in the short time available to us in regard to the questions that have been asked, and maybe an indication of how we might go into the future, and then I'll come back and formally close the meeting. So I'm going to give you the floor again, and if you want to put on your camera, I think you could do so, Jim, because I don't think it made much difference. There is a problem with the audio, unfortunately.
Well, hopefully, if I was breaking up a bit during the presentation, the text was displayed on the screen, and so folks could see what it was saying. I would just like to state that I, for example, don't assume that the statements I made in today's presentation are absolutely and totally correct. It's the result of my examination of the facts as well as I am able. It could be that you would look at the same facts and the same evidence and come up with different conclusions. So there's always room for debate in physics and science, and I certainly welcome it. Part of the message in my talk today was to point out that it looks like there is a rather undeniable trend toward acceptance of binary mechanics postulates and the conclusions one can draw from them, and that these postulates have shown to have a definite real world utility in the quantum technology advances which we've developed here at Binary Mechanics Lab. So whether or not the theory, for example, electron microscopy was used and continues to be used to great benefit, even though physicists continue to debate even such basic questions as what an electron is. Is it a point particle? Is it an object with a definite physical dimension of a radius or whatever, and so forth? So that one advantage of binary mechanics has been to offer new technology which was not previously available. I expect that this technology, that it will be a requirement to use it, whether or not one fully understands the theoretical basis for it, much as electron microscopy is widely used now, even though physicists continue to debate what electrons actually are and other aspects of the related physics that is involved. So thank you again for your attention. I hope that if my voice was interrupted during the presentation, at least you have the text of the talk. And in fact, that text will be published as a paper on the Binary Mechanics website, perhaps within a few hours. So that if you missed any of its content on the screen today, it will be at the Binary Mechanics website. And thanks again for even thinking about some of these problems and issues. I'm very happy to present them for your consideration.
Well, our thanks are due to you, Jim, for having prepared this very illuminating talk with a lot of images and humor and so on. It seemed quite radical, as I said at the beginning, that you are saying, well, all theories that we have out there in the public domain suffer from this contravention of scientific principles and so on. But I think you've adequately sown a lot of doubts in our mind to indicate that possibly is not too wide of the mark. Although you give a word of optimism, which might be slightly more optimistic than some of the things I said earlier, that perhaps things are developing in a positive direction, and maybe younger people are beginning to think in a less biased way about some of these phenomena. And if indeed the future is along the binary mechanics line, we'll be seeing that in the not too distant future. But I think that this talk, which is recorded now, will act as a supplement to the other more specific technical talks that you've given, in the last year or two, and they'll give us a better background, which regard to the thinking that gave rise to the whole fundamental theories, which are using discrete properties of the various parameters and so on. And I think just looking at some of the comments that are coming in, the audio wasn't too bad, and certainly I take the point that the slides were up and all the information is there, and people can look at the recording and pause it if they wish. So that shouldn't be a problem. I think the major problem was actually partly my fault. When we were talking, some of us were talking, and there was a slight delay in the line because the audio isn't quite perfect, and we were maybe talking over each other. So that possibly problem. Although some comment here came in that when you actually switched off your camera, it did improve the matters a little. So towards the end, there were no problems when you were addressing the questions. And indeed, I can say in your summary just now, that was excellent. There was no problem there at all. So I hope those small technical details did not interfere too much with what I thought was a very, very illuminating and valuable lecture, which will give us plenty of opportunity to reflect on these matters again. And I know there will be a bit of a post-mortem, as Vladimir said earlier, in our cosmology discussion tomorrow. So thank you very much. Thank you for the contributions from the media. We've gone through them. Not many were very specific questions for Jim, so you'll forgive me if I didn't entertain too much conversation about them. But thank you very much for all the participants in the green room. There were one or two other people who logged in for a short period of time. I noticed Harry Ricker and Franklin, who logged in for a short time, but they seem to disappear towards the end. So if they have any questions, we can address those again, either in the cosmology discussions or maybe directly. Or indeed, Jim, as a regular participant in our group, will be quite happy, I'm sure, to deal with any of our inputs, as he has always been up to now. So I'd like to end by thanking you all and thanking our speaker today for going to considerable trouble of giving us a very cogent and lucid and illuminating talk. So without further ado, I'm going to wish you all a very good day and end the stream. Good day.